In the previous classes, we started talking about RLC circuits, parallel or series, step response or natural response. And I told you that for both cases, step response or natural response, or for parallel or series, what I have to do is, the first step is to calculate alpha and omega O. Then I will compare between alpha and omega O. If alpha square is greater than omega O square, then I have a specific solution. If alpha square is less than omega O square, I have another solution. If alpha square is equal to omega O square, I have a third solution. So by finding alpha square and omega O square, I can choose one of three different solutions based on, is it step or natural response? Is it RLC parallel or series? I can find different values of alpha. And the next step is to write the equation that you are going to find it for the voltage or the currents. And after that, there will be two different unknowns. Two different constants, sorry. What are those? Maybe A1 and A2, or A1 prime and A2 prime, or beta 1 and beta 2, or beta 1 prime and beta 2 prime, or D1 and D2 prime, or D1 prime and D2 prime. From where I can find all of these constants? I told you from the initial conditions. So after writing the equations, I have to look to the initial conditions. What are those? If your equation is function of the voltage, so I will try to find V of 0. And I will try to find dV of 0 by dt. If I'm using the equation of the current, at that time, I will find I of 0 and di of 0 by dt. I of 0 or V of 0, I'm finding their values before moving the switch. Or I will give you their values if I didn't show you the circuit before moving the switch. But what about di of 0 by dt and dv of 0 by dt? You have to calculate them. How? I know that V, in case of the inductor, is equal to LdI by dt. So if you are finding the current in the inductor and you would like to find dIL of 0 by dt, you have to find V across the inductor of 0 divided by L, because dV of 0 by dt, V is equal to LdI by dt. So if you are finding the current in case of the inductor, you need to find di of 0 by dt, which is equal to VL of 0 over L. So if you are looking for di of 0 by dt, you have to find VL of 0 over L. In case of the capacitor, I is equal to C dV by dt, right? So if you would like to find D, let me write those. So I know that VL is equal to LdI by dt. So if you would like to find dIL of 0 by dt, this guy is equal to VL of 0 over L. So you have to find VL first. If you are looking for the voltage, I know that I in case of the capacitor is equal to C dV by dt, which is the voltage across the capacitor. So if you would like to find dVc of 0 by dt, this guy is equal to IC of 0 over C. These are the two equations I need them to find the two equations to be able to find the two constant values. Are you seeing what I'm talking about, guys? Let us see problem. These are the steps that I'm using for solving any problem related to that. But before I start solving the problem, I have to be sure that I have only one L and I have only one C, and I have only one R. What about if I have different L and different C and different R? Find the equivalent for each. Because you couldn't use the equations that I have already derived unless you have parallel RLC, only one R, one L, one C. Or series RLC, only one R, one L, and one C. You couldn't use your equations unless you have only one R, one L, and one C. So what you have to do is you have to convert your problem to be similar to the circuit that I have already derived. Let us see this problem. And this is similar to one of the problems in the assignment. I'm saying here for this problem, can you please find the roots of the characteristic equation that governs the transient behavior of the voltage if R is equal to 200 and L is equal to 50 millihenry and C is equal to 0.2 microfarad. So what are the roots for the characteristic equation? I told you the characteristic equation is the equation that's function of S, which is S squared plus something multiplied by S plus another constant is equal to 0, which is the polynomial equation. The roots that he is asking about here is S1 and S2, which is equal to negative alpha plus or minus square root of alpha squared minus omega squared. These are the roots. So for finding the roots, I have to find alpha and omega. And then he asked me, will the response be over-damped or under-damped or critically damped? This is depending on what? Excuse me? Depending on alpha and omega, I will compare between them. And I can choose one of these three cases. Over-damped if what? Alpha squared is greater than omega squared. Under-damped if what? Omega squared is greater than alpha squared, and critically if both of them are equal. Then he asked about what is the value of R that will convert your response to be critically damped. So for part C, he's asking about the value of R that will make the response critically damped. So for sure, for part B, I don't have critically damped, right? I have over or under damped because he's asking me for part C, what is the value of R for the response to be critically damped? I'm trying to be smarter than him while I'm reading the problem. But maybe he is smarter than me and he's repeating the same question. So you have to be careful. Anyway, so I will calculate alpha. This is parallel or series RLC. It's parallel. So alpha is equal to 1/2 RC. So I will calculate alpha, which is 1/2 RC, which is equal to 1.25 times 10 to the power 4. Now what's omega? Omega actually, in case of parallel, it is the same like in case of series. So I will not bother myself by omega. But in case of parallel for alpha, I have a certain equation, and in case of series, I have another one. But for omega, it is 1/square root of LC. So I will try to find omega square, which is 1/LC. He calculated it, and he found it is equal to 10 to the power 8. So I'm going to find alpha square, and based on that, alpha square will be equal to 1.25 squared times 10 to the power 4. Sorry, times 10 to the power 8, because it is 10 to the power 4 square. So I will compare between this guy and this guy. Alpha square is greater than omega square or vice versa. Alpha square is greater than omega square. Based on that, which kind do we have? Yes, so based on that, I can say this guy is over-damped. He asked me to calculate S1 and S2. What's S1? Actually, S1 or 2 is equal to negative alpha plus or minus square root of alpha square negative omega O square. So this is what I did here for finding S1, which is negative alpha plus square root of alpha square minus omega O square. It gave me this value. Then I tried to find S2, which is equal to negative alpha negative square root of alpha square minus omega O square. Then I calculated S1 and S2 that he asked me about, and those are the roots for the characteristic equation. Do you have any question, guys, for that? Any question? Okay, what is the next step? He asked me about the response. I said it is overdamped because alpha square is greater than omega O square. Then for the last part, he asked me what is the value of R that causes the response critically damped? When the response will be critically damped? When alpha square is equal to omega O square. So what am I going to do is I'm going to say this guy squared should be equal to this guy. Right? So based on that, I can say for a critically damped, 1 over 2 RC squared is equal to 1 over LC. What do you need? R. Do I have L and C? Yes. Should I change the value for L and C? No. Based on what you said, no, because he didn't say anything about L and C. So I'll keep both of them. I will not change the value of L and C, but I will change R. So I will write that equation, which is alpha square equals to omega O square. I will calculate omega O square, which is equal to 10 to the power 8. Then I have the value of C. Based on that, I can find the value of R. So I can say 1 over 2 RC is equal to 10 to the power 8 under square root. Then 1 over 2 RC is equal to 10 to the power 4. And based on that, I can say R is equal to 10 to the power 6 divided by 2 times 10 to the power 4 multiplied by 0.2. So based on that, I can calculate the value of R, which is equal to 250. So from this equation, I can say that R should be equal to 1 over 2 multiplied by C multiplied by 10 to the power 4. If you try to substitute in the equation, you will find that R is equal to 250. This problem is similar to, I believe, problem number 3 in the assignment. Do you have any question, guys, for this problem? Yes.
If RLC is parallel or series, S1 and S2 remain the same, right?
Yes, S1 or 2, based on what we have already derived for parallel or series, is equal to negative alpha plus or minus square root of alpha square negative omega O square. I have similar equations for parallel and series. The only difference between them is alpha and what you are going to find. So here, for this guy, for parallel RLC, we derived the equation of the voltage. But for series RLC, in case of natural response, we derive the equation of the current. So the component that you are finding is different. So I have two things I have to be careful while I'm dealing with them. In case of parallel RLC, alpha is different than in case of series. And also, in case of parallel RLC, I'm using the equation of the voltage. In case of natural response. But in case of series RLC, I'm using the equation of the current. And vice versa for the step response. For the step response, parallel RLC, I'm finding the equation of the current as a function of the force current. But in case of series RLC, I'm finding the equation of the voltage as a function of the force of voltage. I have to be careful while I'm dealing with that. Any question, guys? Okay. Let us see another problem. This problem is covering everything related to the case. This circuit is parallel RLC. Is it step or natural response? It's natural response. So he asked me for the circuit if V of 0 positive is equal to 12, which means the voltage across this guy, it's equal to 12. So what is the voltage across this guy? 12. What is the voltage across this guy? 12. Because all of them are connected in parallel. This is in case of what? At t is equal to 0 positive only. If t is equal to 1, I have different value. If t is equal to 0 negative, the voltage across the capacitor is equal to what? Is it the same? Yes, because the voltage in case of the capacitor is not changing instantaneously. But what about the voltage across the inductor or the resistor? I don't know. It is depending on the previous case, which he didn't describe it for me. Okay, I have to be careful while I'm reading these problems. For any simple mistake, you can lose everything. So he gave me IL of 0, which is equal to 30 milliamps. The current here is equal to 30 milliamps. Can you find the current in this guy? At t is equal to 0 positive. The current in the resistor at t is equal to 0 positive. Is it easy to find it? It is equal to, it's equal to 12 divided by 200. Excellent. Can I find the current in the capacitor at t is equal to 0 positive? Yes, how? Excuse me? Yes, I will say summation the current for that node is equal to 0. So if this guy is leaving, this guy is leaving, this guy is leaving, then IC plus IR plus IL is equal to 0. So IC of 0 positive is equal to negative the summation of IR of 0 positive and IL of 0 positive. Do we need IC of 0 positive? I don't know, maybe. Do we need IR of 0? Maybe. Do we need IL of 0? Maybe. Do we need the voltage at 0 time? Maybe. So I have to be careful and I have to know why he gave me those values. Now he is asking me, find the initial current in each branch. I think it's very easy. What is the initial current here? IR, it is equal to 12 times 200, divided by 200. What about the current in this guy? It's given 30 milliamps. What about the current in this guy? It is negative, the summation of this guy and this guy. And this is what I did here. So IL of 0 positive is equal to IL of 0 negative is equal to 30. But IR of 0 positive is equal to V of 0 positive divided by R, which is equal to 12 divided by 200, which is equal to 60 milliamps. Then I said summation the current is equal to 0 for the node that I have. I can say IC 0 positive is equal to negative IL of 0 positive, negative IR of 0 positive, which is equal to negative 90 milliamps. This is IC of 0 positive. What about IC of 0 negative? Is it the same for the capacitor? No, it's different. what's its value? It was 0 because the capacitor was charging at that time. Am I right? The capacitor was looking like an open circuit and it was charging. So I have already calculated all initial currents that he asked me about. Any question for that? Everything in the problem is depending on that step. This is very, very important step. Any question? No? Okay, let us see the next part. Find the initial value of the voltage dV by dt. How to find dV by dt? He would like to find dV of 0 by dt. How to find it? Without looking to the notes. Any equation is giving me dV by dt. I don't have many equations. I have only two elements, the inductor or the capacitor. Those, when I started studying them, I started seeing the first derivative, and I started being scared because of the first derivative. So I'm expecting that one of the equations for the inductor or the capacitor is function of dV by dt. Let me remember, what about the voltage across the inductor? It is LdI by dt. So dV by dt may be for the capacitor. Yes, the current in the capacitor is equal to C dV by dt. So generally speaking, if I asked you to calculate dV by dt at t is equal to 0, you have to find the initial current in the capacitor. Because I is equal to C dV by dt, and based on that, I can say dV for the capacitor of 0 divided by dt is equal to IC of 0 over C. I subscript C. Because some of you will say, oh, we will cancel C with C, which is right. This is the subscript. Okay? So, whenever I'm asking you to find dV of 0 by dt, you have to find IC of 0 by dt. Whenever I'm asking you to find DIL of 0 by dt, you have to find VL of 0 over there. So what I need for finding dVC of 0 by dt, I need to find IC of 0. Do I have that and do I have C? Yes, C is equal to 0.2 microfarad. I have already calculated this guy. So I can say dV of 0 by dt is equal to IC of 0 divided by C. And IC of 0 is equal to negative 90 milli divided by C, which is 0.2 microfarad. So it will be 0.2 times 10 to the power negative 6. If you try to calculate this guy, it will give you negative 450 kilovolt per second, because this is dV by dt. The unit will be volt per second. Any question for that? Okay, let us see part C. Yes, go ahead.
So the dV by dt is like the speed of the capacitor discharging.
Yeah. Now he is looking for finding expression for V of t. Find an expression for V of t. Do you remember the equation for V of t? In case of parallel RLC, natural response, what is the equation for V? Excuse me? Anyone? What is the equation for V? Do you remember it? Yes, I have first to calculate alpha and omega. Don't ask me about the equation. Ask me first about alpha and omega, because based on alpha and omega, I can choose one of three cases. So I have to calculate alpha first, which is 1 over 2 RC. and omega, which is 1 over square root LC. And this is what I did here. I tried to calculate alpha and omega, and I found that alpha square is equal to this value, and omega square is equal to this value. So I found this case is overdamped case, then S1 and 2 are equal to negative alpha plus or minus square root of alpha square negative omega O square. I tried to calculate S1 and calculate S2. Then, at that time, you are talking about the first case, which is V of t equals A1 times e to the power S1t plus A2 times e to the power S2t. So the next step after calculating S1 and S2, I'm going to substitute in this equation. V of t is equal to A1 times e to the power S1t plus A2 times e to the power S2t. I got that equation, which is equal to A1 times e to the power negative 5,000 t plus A2 times e to the power negative 20,000 t. I have already almost solved the problem, but what I need to find the value of A1 and A2 from where I can find them from the initial conditions. So I will say V of 0, let t is equal to 0. So V of 0 will be equal to A1 plus A2 because e to the power 0 will be 1. So based on that, I can say V of 0 is equal to A1 plus A2, and I know the initial voltage across the capacitor was equal to 12. So based on that, I said 12 is equal to A1 plus A2. Then I have to find the derivative of V. So dV by dt is equal to what? It is equal to A1 times S1 e to the power S1t plus A2 times S2 times e to the power S2t. I will find the first derivative for those. Then I will find dV of 0 by dt. So dV of 0 by dt will be equal to A1 S1 plus A2 S2. This is 0 positive. What is dV of 0 by dt? I have already calculated it here, which is negative 450. So I will plug negative 450, which is equal to A1 S1 plus A2 S2. Right now, I have two different equations. This equation, which is function of A1 and A2, and this equation, which is function of A1 and A2. I will solve these two equations. I have S1 and S2, but I need A1 and A2. So both of them are function of A1 and A2. I will solve these two equations together to find A1 and A2. You can use whichever method you like, elimination or substitution method for solving these two equations. Or even you could use your calculator. After finding A1 and A2, what is the next step? Don't leave them. Write the equation of the voltage. V of t, because this is what I need, is equal to A1 times e to the power, which is this, negative 5,000 t plus A2 times e to the power negative 20,000 t. This is V of t. Don't ask me what is the value of t. Don't ask me that question. This is the voltage at any time t. That's right, my friend? This is the voltage at any time t. Don't ask me that question. It is the voltage at any time t. Don't ask me about the value of t, because this is the time. This is the instantaneous voltage at any time. Okay, guys? If t is equal to 0, if I would like to be sure that my answer is right, try to find V of 0. So if t is equal to 0, e to the power 0 is equal to 1, and e to the power 0 is equal to 1, then negative 14 plus 26 is equal to, which is the initial voltage. I'm right. Right? This is to be sure that what I did is right. Then he asked me to sketch V of t in the period from 0 to 250. I'm not asking you to plot the exact curve. Choose different points and then sketch that guy. You will find that this guy will be something like that. Choose like point here at t is equal to 0. Choose another point here. I choose this point and I choose any 3 points and connect them. This is curve actually. I'm expecting it will be a curve. I asked you to plot it between 0 and 250. So you will put t is equal to 0, t is equal to 250, and t is equal to 100, for example. And then connect these 3 points, and this is curve. It is not straight line, right? So don't draw a straight line. Draw a curve. Connect it to these 3 points. Imagine that I found 3 points at 250 and at 100, and that's so I will connect those points. That's it. I'm not asking you to draw the exact curve. I ask you to sketch only, and any sketch is acceptable since you are choosing like different points. If I asked you about that for the final, maybe I will not, but if I ask you. Last part here, I asked you to derive expression for IR, IL, and IC. Derive expression for the current IL, IR, and RC, IC. Why I asked you to derive expression? Because this expression will be function of time. It will not be a constant value. And from today, we are going to see the current or the voltage as function of time. We will not see the voltage or the current only constant. We will see the voltage or the current as function of time. And next week, I will start talking about steady state. So the voltage and the current is sine wave or cosine wave. And this will be the last chapter I will talk about. So he asked me to find IL, IC, and IR. I give you the equation of the voltage at any time. Can you find the equation of the current in the resistor? IR is equal to what? V over R. This is the easiest one. IR is equal to V over R. What about IL or IC? IC is equal to what? C dV by dt. And I think this one is very easy as well. What about IL? 1 over L integral of V dt. And most of you hate dealing with integrals. That's why I can avoid finding the integral by saying what? Summation of the current for that node is equal to 0. Once you found IR and IC, you can say IL is equal to negative IR negative IC. Yes, IC, and this is what I did here. I found IR, which is equal to V divided by 200. And I found IL by saying 1 over L integral of V dt, and I found IC and I checked. So if you try to see in the notes, IL is equal to 1 over L integral of V dt plus the initial condition, and IC is equal to C dV by dt, and then I checked IL is equal to negative IR negative IC. I think that's enough for today. I'll see you on Friday